And here are the guts of the question. Okay, in case you're too lazy to find where the question is on your sheet, they give you this polynomial. They say it has such and such zeros. Okay, so the first thing you got to work out is this B, C, and D, these coefficients. All right, they've already told you it's monic. Can we work out what B, C, and D are? Now, there's two ways to go about this. Okay, number one, well, you tell me what's the first way that jumps out to your mind of how you're going to solve for B, C, and D? What would you do to work them out?
P of those things.
Yeah, good. So we would use, just as we've been discussing, the special version of the remainder theorem, the factor theorem, because if there are zeros here, right, that means that when you divide by x, or when you divide by x minus 3, or when you divide by x plus 3, you're to get no remainder. Okay? So when you sub in p of 0, you'll get 0. Sub in p of 3, you'll get 0. Sub in p of minus 3, you'll get 0. And then you can solve simultaneously. You get 3 equations. There's the first way you can go about it. But there's kind of a quicker way because of this specific kind of question, right? Because what does it mean for it to have zeros here, right? Well, it means that there are factors that correspond to those zeros. So if the 0 is 0, okay, the factor that corresponds to that is x, yes? If there's a factor if there's a 0 at 3, then the factor that corresponds to that is x minus 3. And likewise, for the 0 of minus 3, it corresponds to the factor x plus 3. Okay? Now, the reason why I can do this is because I already know it's monic. Okay? And there are only going to be 3 factors because it's a cubic. Right? So I can go ahead and expand that, and you'll get x cubed minus 9x. Okay? So therefore, in this particular case, it looks like B is 0, D is 0, and C is minus 9. Okay, you can go ahead and verify that. That's not actually the interesting part of the question. I want to get from that to the next bit. Let's graph it, okay? Now, because they already told us what the zeros are, right? And it's a cubic, you can actually know with some confidence what it's going to look like. If there are zeros at minus 3, 0, and 3. Okay? Now, this is a cubic, right? So it's going to have this wiggle thing, but I have a question for you. How do you know whether it's this kind of wiggle or that kind of wiggle? Yeah, good. You look at this is why we introduced all this language, right? You look at the leading coefficient, and it's positive, right? Well, actually, it's positive from over there. Okay? So therefore, as x tends to infinity, a positive coefficient means that y also tends to infinity. Okay? So you're going to get this graph. Okay, so far so good, right? Now there's my graph, but here's where it starts to get kind of... the last part of the question is not just solve, but hence solve this inequality. Okay? Now when I looked at this inequality, I was like, what does this have to do with anything? Right? Have a look at what we've got here. This. Right? Yeah, we'll get there, but that's not as intuitive as it might sound, and there are problems with it as well. You've got this. Okay, so I could solve this quite easily. That's pretty easy to solve off the graph, right? Namely, where is this thing positive? So just looking at it, it's positive between here and here. Right, so I'm just drawing out like a number line solution, right? I'm not including the boundaries because that boundary is not included. And also it's positive over here. Okay? So there's that, but what does that have to do with this? Okay, well, 2 things. Firstly, you could do what Jesse suggested, which is divide both sides by x squared. Okay, I could kind of sort of, okay, basically, right? I'm converting to something which would be actually useful. Now, the reason why dividing by x squared is sort of a good idea is because x squared is almost always positive. Right? So that means I don't have to muck around with which direction the inequality sign will go in. Okay? So sure enough, this is x squared minus 9 on x, and that's still 0. Okay? The reason why you've got to be careful is because, well, what about x equals 0? Okay? Now, the reason why in this case that actually happens to not be a problem is because it's a non-inclusive boundary, right? So x can't equal 0. Okay? But it's more dangerous because sometimes x can equal to 0, so you've got to be really careful with dividing by things like that. Okay? I think a better way to think about it is like so. what I solved, this inequality, right, is really this inequality. Okay, does that make sense? Now remember, think back to further graphs and locus when we were trying to do like the sign of a graph, and we were trying to shade to see where it went through, when we had like rational functions, that kind of thing. So we would say, look, draw this factor line, then draw, these two factor lines, x plus 3, x minus 3, okay? You draw them through, and that's where you know it's positive and negative, okay? But, can you see that this part is the same in both questions, but what's different is that this is actually 1 over x squared minus 9, right? So being that these two parts are the same, I'm just going to stop worrying about them for a second. And when you look at the x and the 1 over x, wrong pen. Can you see that when this is positive, this is also positive, right? And when this is negative, this is also negative. So therefore, since as factors being positive or negative, they behave in exactly the same way, solving these two inequalities will give me exactly the same result. They are equivalent inequalities, okay? So therefore, this answer that we got, right, for this inequality is the same answer as for this, okay? So the actual answer was minus 3 to 0 or greater than 3. It's the same. Now just to prove it to you, okay, what does this inequality actually look like? Well, if you graph it, it's pretty simple to graph. Quickly. It's got a vertical asymptote. Where? 0. It's got an oblique asymptote. Where? At y equals x, it actually goes through the origin. Okay. Then when you solve it to find your intercepts, surprise, surprise, your intercepts are minus 3 and 3. So what does this one look like? It looks like this. Now, if we're solving for when it's greater than 0, to the right of here, but I can't go past there because there's an asymptote. And then over here, well, from here to the right, which is exactly the same. Okay, so you can see, not just algebraically, but geometrically, they are equivalent. All right?